Vector Database Roadmap for Backend Developers Introduction. A vector database is a database designed to store, search, and retrieve high-dimensional vector embeddings. Backend developers often learn vector databases to build. Check. AI search systems. Check. Semantic search. Recommendation engines. Chatbot memory. Check. RAG applications. Check. Document search. Image similarity search. Check. Personalized content systems. A common learning topic is: how can backend developers learn vector databases step by step? This guide explains. COAX, Vector Database Basics. COAX, embeddings, semantic search, similarity search, indexing, RAG architecture, Java backend integration, Spring Boot integration, popular vector databases, real-world use cases, interview questions, roadmap for backend developers. This is one of the best roadmaps for backend developers moving into AI-powered backend systems. Simple definition. A vector database is a database that stores data as vectors and helps find similar items using mathematical similarity search. Example: instead of searching only by exact keyword, Java Spring Boot authentication. A vector database can understand meaning and find related content, like JWT login security, OAuth 2 backend authentication, Spring Security API protection. Why backend developers learn vector databases? Backend developers already understand APIs, databases, indexing, caching, search systems, authentication, system design. Vector databases help backend developers build. Check. AI search, smart recommendations, chatbot knowledge base, document Q&A, semantic product search, personalized feeds, fraud detection, similarity matching. Traditional database versus vector database. Feature: traditional database, vector database. Data type: rows and columns, vector embeddings. Search type: exact match, similarity search. Query example: where name equals Java. Find similar meaning. Best for transactions, AI search. Examples: PostgreSQL, MySQL, Oracle, Pinecone, Milvus. Weaviate, Qdrant, Chroma Basic Architecture. Typical vector database architecture. User query, embedding model, query vector, vector database search, similar documents, backend API, user response. Step 1. Understand what embeddings are. Embeddings are numerical representations of text, images, audio, or data. Example: Spring Boot security can become a vector like 0.12, -0.34, 0.88, 0.45. The vector captures meaning. Similar meanings produce similar vectors. Example: Spring Security JWT, backend authentication, API login token. These may be close to each other in vector space. Step 2. Understand similarity search. Vector databases search by similarity. Common similarity methods. Method: meaning. Cosine similarity measures angle between vectors. Euclidean distance measures straight line distance. Dot product measures vector alignment. Simple idea: closer vectors equals more similar meaning. Step 3. Learn semantic search. Semantic search means searching by meaning, not just exact keywords. Traditional search. Query: car loan. Result: pages containing car loan. Semantic search. Query: vehicle financing. Result: car loan, auto finance, monthly payment, APR. This is very useful for search, knowledge bases, documentation search, customer support, product search, AI assistance. Step 4. Learn vector database use cases. Common backend use cases. COP, document search. COP, chatbot memory, recommendation systems. COP, image similarity. COP, product matching. COP, fraud pattern detection. COP, resume matching. COP, article recommendations. COP, duplicate detection. COP, RAG applications. Step 5. Understand RAG. RAG means retrieval augmented generation. It combines vector search, backend APIs, large language models. Architecture. User question: Create query embedding. Search vector database. Retrieve relevant context. Send context to LLM. Generate final answer. Example. Question. What is our refund policy? VectorDB finds refundpolicy.pdf, termsconditions.docx, supportarticle.12. LLM generates answer using retrieved documents. Step 6. Learn popular vector databases. Vector database best for Pinecone. Managed cloud vector database. Milvus, large-scale open-source vector DB. Weaviate, AI-native vector database. Qdrant, fast open-source vector search. Chroma, simple local AI RAG projects. pgvector, PostgreSQL vector extension. Hybrid search, OpenSearch vector search. Enterprise search systems. Step 7. Start with pgvector. For backend developers, pgvector is a good starting point because it works with PostgreSQL. Architecture. Spring Boot API, PostgreSQL plus pgvector. Vector similarity search. Example, table. Create table documents. ID serial primary key. Content text. Embedding vector 1536. Search example. Select content from documents. Order by embedding 2.12.44.87. Limit 5. Good for small to medium projects. Spring Boot apps. Existing PostgreSQL systems. Simple RAG applications. Step 8. Learn how embeddings are created. Embeddings are created using embedding models. Examples: OpenAI embeddings, Hugging Face models, sentence transformers, Cohere embeddings, Google embedding models, local embedding models, flow, text, embedding model, vector, store in vector database. Example: Java Spring Boot tutorial. Becomes. Step 9. Understand document chunking. Large documents cannot always be stored as one big text. They are split into smaller chunks. Example: large PDF, chunk 1, chunk 2, chunk 3, chunk 4. Each chunk gets its own embedding. Why chunking matters. A cross-section of code. Avoid sending huge text to LLM. Retrieves only relevant sections. Improves RAG accuracy. Common chunk size. 300 to 1,000 tokens. Step 10. Store metadata. Vector databases usually store metadata with vectors. Example: Document ID 101. Title: Spring Boot Security Guide. Category: Java. Author: Newman. Created date: 2026-06-04. Metadata helps filter results. Example: search similar documents only where category equals Java. Step 11. Understand indexing. Vector databases use indexes for fast similarity search. Common index types. Index usage: HNSW, fast approximate nearest neighbor search. IVF, large-scale vector search. Flat, exact but slower search. PQ, compression for large datasets. Simple idea. Indexing makes vector search faster. Without indexing, search compares with every vector. With indexing, search quickly finds nearest vectors. Step 12. Learn approximate nearest neighbor search. Vector search often uses ANN. ANN means approximate nearest neighbor. It finds similar results quickly, but may not always be 100% exact. Why use ANN? Faster search. Handles millions of vectors. Good enough for semantic search. Better scalability. Step 13. Understand hybrid search. Hybrid search combines keyword search, vector search. Example: keyword search plus semantic search. This is useful because vector search may understand meaning, but keyword search is still useful for exact terms. Example: query, Spring Boot, JWT 0.12.6 error. Keyword search helps match. JWT 0.12.6, Spring Boot. Vector search helps match meaning. Token parsing issue. Authentication library migration. Best backend search systems often use hybrid search. Step 14. Learn vector database CRUD operations. Backend developers should know basic operations. Insert vectors. Update vectors. Delete vectors. Search vectors. Filter by metadata. Batch insert. Re-index data. Example flow. Upload document. Extract text. Split into chunks. Create embeddings. Store vectors. Step 15. Build first simple vector search app. Example project. AI article search system. Architecture. React UI. Spring Boot API. Embedding service. Vector database. PostgreSQL metadata. Features. Upload article. Generate embeddings. Search by meaning. Return similar articles. Filter by category. Step 16. Spring Boot plus vector database integration. Typical Spring Boot flow. Controller, service, embedding client, vector database client, response DTO. Example controller. REST controller. Request mapping, API search. Public class search controller. Private final search service, search service. Public search controller, search service, search service. This search service equals search service. At get mapping, public list search result search at request param string query. Return search service semantic search query. Step 17. Example service layer. At service, public class search service. Private final embedding service, embedding service. Private final vector store, vector store. Public search service, embedding service, embedding service. Vector store, vector store. This dot embedding service is embedding service. This dot vector store is vector store. Public list search result, semantic search, string query. List double, query vector equals embedding service dot create embedding, query. Return vector store dot search query vector 5. Step 18. Learn Spring AI. Spring AI helps Java developers integrate AI models and vector stores. Common features. Embedding models, chat models, vector stores, RAG support, prompt templates. Spring AI architecture. Spring Boot app. Spring AI. Embedding model. Useful for Java backend developers building AI applications. Step 19. Learn data pipeline design. Vector database systems need pipelines. Example. PDF upload, text extraction, cleaning, chunking, embedding generation, vector storage, search API. Common tools. Check. Apache Tika, PDFbox, Spring Batch, Kafka, RabbitMQ, S3, PostgreSQL, Redis. Step 20. Learn batch ingestion. For large data, use batch processing. Example, 10,000 documents. Spring Batch job. Generate embeddings. Store in VectorDB. Why batch matters. Avoids API rate limits. Handles large files. Retries failed records. Improves reliability. Spring Batch is very useful here. Step 21. Learn real-time ingestion. For real-time systems. New article created. Kafka event. Embedding consumer. VectorDB insert. Example event. Article ID 1001. Title Spring Boot JWT Guide. Content. Useful for article search, product search, recommendation systems, chat memory. Step 22. Learn vector search API design. Example API. Get/API search. Query Spring Boot authentication. Response. ID 101. Title Spring Security JWT Guide. Score 0.91. ID 102. Title OAuth 2 Login with Spring Boot. Score 0.87. Good API response should include title, matched content, similarity score, metadata, document link. Step 23. Understand similarity score. Vector search returns a score. Example. 0.95 equals very similar. 0.60 equals somewhat similar. 0.20 equals weak match. Backend developers should tune. Check. Top K. score threshold, filters, ranking, hybrid search weights. Example: return only results where score greater than 0.75. Step 24. Learn filtering. Metadata filtering improves results. Example: search only Java articles. Request: Java, query, authentication, category, Java. Search process: vector similarity plus category filter. Useful filters: category, author, date, tenant ID, user ID, document type, language. Step 25. Learn multi-tenant vector search. In SaaS systems, each customer should only search their own data. Example: tenant ID equals organization 123. Architecture: user query, auth token, extract tenant ID, vector search with tenant ID filter. Very important for SaaS apps, enterprise apps, organization-based apps, private knowledge bases. Step 26. Learn security. Vector database security is important. Best practices: never expose VectorDB directly to frontend. Search through Backend API. Validate user permissions. Filter by tenant ID. Secure API keys. Encrypt sensitive data. Avoid storing private data unnecessarily. Bad design. React app means vector database. Better design. React app means Spring Boot API means vector database. Step 27. Learn performance optimization. Common performance techniques: batch embedding generation, cache frequent queries, tune top K, use metadata filters, use proper indexes, avoid huge chunks, use async processing, monitor latency, use pagination, compress old vectors. Example: user query, Redis cache, check. Vector search, return results. Step 28. Learn evaluation. You need to test search quality. Important metrics: metric, meaning, precision, how many returned results are correct. Recall, how many correct results were found. Latency, how fast search responds. Relevance, how useful result is. Top K, accuracy, correct result appears in top results. Example test: query, Spring Boot JWT, expected, JWT authentication guide, actual, OAuth guide, Spring security guide, JWT guide. If correct result appears too low, tune ranking. Step 29. Learn RAG evaluation. RAG systems need extra testing. Check. 1. Retrieved documents are relevant. Generated answer uses retrieved context. 2. Answer does not hallucinate. Citations are correct. 3. Private data is not leaked. 4. Answer quality is consistent. Common RAG problem: wrong document retrieved. Then, the LLM gives a bad answer. Good retrieval is very important. Step 30. Learn production monitoring. Monitor: search latency, embedding generation failures, vector DB availability, top query terms, no result searches, ingestion failures, API cost, storage growth. Useful tools: Prometheus, Grafana, EOK Stack, OpenTelemetry, CloudWatch, Datadog. Vector database roadmap beginner level. Learn: embeddings, semantic search, similarity search, vector database basics, top K search, metadata, basic RAG. Build: simple document search app, intermediate level. Learn: chunking strategies, indexing, hybrid search, filters, Spring Boot integration, pgvector, Pinecone, Qdrant, Milvus basics, batch ingestion. Build: AI knowledge base using Spring Boot advanced level. Learn: check. Multi-tenant vector search, real-time ingestion, Kafka event pipeline, Spring batch ingestion, distributed vector search, RAG evaluation, observability, security, cost optimization. Build: enterprise RAG platform, recommended learning path phase 1. Core concepts. Learn: Check. What vectors are? What embeddings are? Cosine similarity, semantic search, nearest neighbor search. Goal. Understand why vector databases are different from relational databases. Phase 2. Hands-on with pgvector. Learn. PostgreSQL pgvector, vector column, insert embeddings, similarity query, metadata filtering. Build. Article semantic search system. Phase 3. Learn dedicated vector DB. Choose one. XC, Qdrant, Pinecone, Weaviate, Milvus. Build. Document Search API, Phase 4. Integrate with Spring Boot. Learn. Check REST API design. Check Embedding service. Check Vector Search service. Check DTO response. Check error handling. Check pagination. Security. Build. Spring Boot Semantic Search Microservice Phase 5. Build RAG application. Learn. Document upload, text extraction, chunking, embeddings, vector retrieval, LLM answer generation, source citation. Build. Chat with PDF application. Phase 6. Production design. Learn. Check multi-tenancy, check indexing, check caching, monitoring, retry logic, cost control, batch processing, security. Build. Production-ready AI knowledge-based Java backend developer roadmap. For Java developers. Java. Spring Boot, PostgreSQL, pgvector, Spring AI, Vector Search API, RAG application. Recommended stack. Java 17+, Spring Boot 3, Spring AI, PostgreSQL plus pgvector, Redis, Kafka, Docker, OpenAI or local embedding model, React frontend, Spring Boot plus VectorDB system design, architecture, React frontend, Spring Boot API gateway, search service, embedding service, vector database, PostgreSQL metadata DB, with ingestion, admin uploads document, Spring Boot upload API, store file in S3, Kafka event, embedding worker, chunk text, generate embeddings, store vectors, real-world example, example AI knowledge base, architecture, React UI, Spring Boot backend, document service, embedding service, vector database, LLM API, features, upload PDFs, search documents, ask questions, generate answers, show source citations, filter by category, user-based access control, backend responsibilities, backend handles. Check authentication, check authorization, check document upload, check extraction, check chunking, check embedding generation, check vector search, check metadata filtering, check RAG orchestration, check audit logging, check monitoring. Front-end responsibilities, front-end handles. Search box, chat UI, document upload screen, loading state, source display, user feedback, result highlighting. Common beginner mistakes. 1. Using huge chunks. Large chunks reduce search quality. Better. Use smaller, meaningful chunks. 2. Ignoring metadata. Without metadata, filtering becomes difficult. Always store, comma. Check. Document ID, tenant ID, category, source, created date. 3. No access control. Dangerous in SaaS systems. Always filter by tenant ID, user ID, permission 4. Thinking VectorDB replaces SQL. Vector databases do not replace relational databases. Best design. PostgreSQL for business data. VectorDB for similarity search. 5. Poor embedding model choice. Bad embeddings create bad search results. 6. No evaluation. Without evaluation, search quality is guesswork. 7. No retry logic. Embedding APIs can fail. Use. Check. Retries, queues, dead letter handling, batch processing. Best practices. Use VectorDB for similarity search. Use SQL database for transactional data. Store metadata with every vector. Use chunking carefully. Add tenant ID for SaaS apps. Secure vector search behind backend APIs. Cache frequent queries. Monitor latency and errors. Evaluate retrieval quality. Use hybrid search for better results. Batch large ingestion jobs. Use Kafka for event-driven ingestion. Keep original source documents. Version embeddings when model changes. Re-embed data after changing embedding model. Vector database interview questions. 1. What is a vector database? A vector database stores and searches high-dimensional vectors, usually created from text, images, or other data using embedding models. 2. What are embeddings? Embeddings are numerical representations of data that capture meaning. Example: Java backend developer becomes 0.12, negative 0.45, 0.78. What is semantic search? Semantic search finds results based on meaning instead of exact keyword matching. 4. What is cosine similarity? Cosine similarity measures how similar two vectors are based on their direction. 5. What is RAG? RAG stands for Retrieval Augmented Generation. It retrieves relevant documents from a search system and sends them to an LLM to generate a better answer. 6. What is top K? Top K means returning the top number of most similar results. Example: top K equals 5. Returns the 5 most similar documents. 7. What is hybrid search? Hybrid search combines keyword search and vector search. 8. Does vector database replace PostgreSQL? No. Use PostgreSQL for transactional data and vector databases for similarity search. 9. How do you secure vector search in SaaS? Use metadata filtering with tenant ID, user ID, roles, and permissions. 10. How do you improve vector search quality? Use pause, better embeddings, proper chunking, metadata filters, hybrid search, ranking, evaluation. Vector database plus Spring Boot example. Request GET API vector search query Spring Boot JWT. Response: title Spring Security JWT authentication. Score 0.92. Source Security Guide PDF. Title OAuth 2 Resource Server. Score 0.86. Source OAuth Guide PDF. Query: service generates embedding. VectorDB searches similar vectors. Metadata is fetched. Results returned to front end. Vector database versus Elasticsearch. Feature vector database Elasticsearch. Search type: semantic similarity. Keyword: full text search. Best for AI search, RAG logs, documents, keyword search. Style: meaning-based, term-based, ranking vector similarity. Text relevance: can combine? Yes, yes. Best production systems often combine both. Vector database versus cache. Feature: VectorDB cache. Purpose: similarity search. Fast key value lookup. Example: find similar documents. Get user session. Tool: Pinecone, Qdrant, pgvector. Redis. Query type similarity. Exact key. Vector database project ideas. Beginner projects. Check. Semantic article search. Check. Similar blog recommendation. Resume search system. Check. FAQ search API. Check. Product similarity search. Intermediate projects. Chat with PDF. AI customer support bot. Spring Boot RAG API. Semantic search for e-commerce. Code snippet search engine. Advanced projects. X multi-tenant enterprise knowledge base. X real-time recommendation engine. X hybrid search platform. X AI-powered support ticket routing. X document intelligence platform. 30-day learning plan. Week 1. Basics. Learn. Check. Embeddings. Check. Vectors. Similarity search. Semantic search. Cosine similarity. Practice. Create simple embeddings. Compare text similarity. Search small data set. Week 2. Vector database. Learn. Qt pgvector, Qdrant or Pinecone. Qt vector insert. Qt vector search. Qt metadata filtering. Practice. Store article embeddings. Search similar articles. Week 3. Spring Boot integration. Learn. REST APIs, embedding service, vector search service, DTO response, error handling. Practice. Create API/search endpoint. Return top K results. Add category filter. Week 4. RAG project. Learn. Check. Document upload. Check. Chunking. Vector retrieval. LLM integration. Citations. Monitoring. Practice. Q. Build chat with PDF app. Q. Add authentication. Q. Add tenant filtering. Final summary. Vector databases are very important for modern AI-powered backend systems. Important concepts include: check, embeddings, semantic search, similarity search, vector indexing, metadata filtering, hybrid search, RAG, Spring Boot integration, multi-tenancy, production monitoring. Backend developers already understand: check, APIs, check, databases, system design, check, security, scalability. This makes vector databases easier to learn. Key idea: a vector database helps backend developers build intelligent search, recommendation, and RAG systems by searching data based on meaning instead of exact keywords.